got, right, hydrogen here. This is a 3H azepine. So this is the third synthesis. Now let's see fourth synthesis. The fourth synthesis is from azoles. Here pyrroles can also act as a diene. They can involve in Diels-Alder reaction, thereby they are going to produce, right, azepines. So pyrrole, let's take the reaction. Pyrrole is a 5-membered heterocyclic compound with nitrogen as heteroatom. Now this has a CO2Me. So this is on reaction with dinophile. So the dinophile here I am taking acetylene derivative, diethyl acetylene dicarboxylate. So now it is in presence of, right, aluminum trichloride and the solvent is DCN. Now this is undergoing which reaction? Diels-Alder reaction. How the Diels-Alder reaction is taking place? Now this pi bond is shifted here. Now the pi bond is going to attack onto this carbon. Now one of the pi bond is attacking onto this carbon atom. After that it forms a cyclic adduct. Okay, due to shifting here we got the double bond. Right, now this attached to these two carbons and these two carbons. In this we have a nitrogen, so I'm going to write that nitrogen at this place, nitrogen, and this nitrogen has a substituent CO2 That's okay. Here we have a triple bonded compound. One pi bond has attacked here and one pi bond of pyrrole has attacked here. We got this one, and this position we have CO2Me, and here also we have CO2Me. This is the cyclic adduct formed in the Diels-Alder reaction. So after that, this Diels-Alder reaction adduct undergoes cycloaddition reaction in presence of light. So in presence of light, whatever the two pi bonds are there, this pi bond attacked here. Now this pi bond is going to attack here. This is undergoing 2pi cycloaddition reaction. Undergoing 2pi cycloaddition reaction. This 2pi cycloaddition reaction going to give prismane type intermediate. So this is going to give prismane type intermediate. The intermediate is, yes, here we have CO2 and we got the bond. Here also we got the bond. So this is the intermediate formed there. Now this intermediate is on heating at 200 degrees centigrade. This intermediate on heating at 200 degrees centigrade. This is undergoing at a ring expansion. So this expansion is going to give a 7-membered ring. You see, carefully you observe. So now here I am going to shift this bond to here. Okay, then I am going to shift this bond to here, this bond to here. Okay, first I shifted this bond here in between two carbons, then after immediately, so here the adjacent carbon bond, this bond, so this carbon bond shifted here. So meanwhile you shift this bond to, yes, here. So now these are the rearrangement. First we shift this bond here, this bond and this bond. So you can easily understand this. We are shifting this bond, therefore we have to break down this bond. That's why we break down this bond. Now that's why we have to break down this bond. We bond shifted to there. So now after that you can see that is going to form a 7-membered ring. Yes, this is going to form a 7-membered ring. 7-membered ring. So 7-membered ring has formed there. Yes, with the nitrogen has heteroatom and nitrogen has CO2Me substituent, and the shifting of this bond we are going to get a double bond at the second position of nitrogen. You can see that and next continuously we can directly write double bonds at this position. And here you can see that after 1 2 3 1 2 3, after 1 2 3 there are CO2 Me substituents. Here also we have the CO2 Me substituent. So this is the method which involve synthesis of azepines. So friends, here in this video we just discussed about the synthesis of azepine. So synthesis of azepine, I mentioned 4 methods. The first one, second one, third one and fourth one. So first method is a valency bond isomerization. Second one from azerines. Third one from phenyl azide. Last one from azoles. So friends, this is about synthesis of azepine. Thank you.